Okay, let's take a crack at question 4. So let's go to jump. Let's get rid of this from question 3. And let's go ahead and say analyze, fit y by x. We're going to put in the forecasted high temperature. That's going to be our x variable, and our y variable is going to be total attendance. So let's see if we can use the high temperature as a way of predicting the total attendance. I'm going to click on OK. So the first thing I do is I see a scatter plot here, and I'm going to ask myself the question, does this look like a linear relationship? And the answer is yes, in general it does, although we have a few points up here that might be problematic. So all throughout the lab we're going to be considering what to do about those particular points. But we don't want to take them out as outliers, at least not at this point in time. So I'm going to click on the red triangle and I'm going to say fit line, and now I get all of the main output for a single regression. I've asked you to reproduce linear fit, summary of fit, analysis of variance, and parameter estimates. So you can see those are right here: linear fit, summary of fit, analysis of variance, and parameter estimates. And so as usual, you can get the hidden menu. I decided to make my hidden menu visible all the time, and then click on the cross tool here, highlight everything, Control C to copy, go back to the Word document, paste special, and then bitmap, and OK. That gives us all the output in a very nice legible format. So this is our equation: total attendance equals an intercept plus B1 times X1, and the null hypothesis is that this 29 coefficient would be equal to 0. So we would write in that HO is that the B1 equals 0 and B1 does not equal 0. Easy way to put that. Okay, both variables have to be continuous because that is what we have for regression. And then the tests that I'm choosing, the F test is for the whole model, and T tests for each coefficient. And in fact, we only have one here, the B1. And my p-value, as I go back up here, you can see in both cases these are actually identical. For single regression, it's less than 0.05. It's less than 0.001, and so I reject the null hypothesis. Because p less than 0.0001. Those are what we call the technical tests. Now for the business test, the R squared is 0.37, so we'll fill that in, 0.37. And the interpretation is we have explained 37% of the variation in the attendance by the temperature. And the RMSE is, let's see here, root mean square error, that's 751. Or 752. The interpretation is that in about 66% of the time will be up to 752 people off in our estimate of attendance. And so the definition of RMSE, remember, that is the standard deviation of the errors in the residuals. And so this is calculated across the range of predictions we're having. So this is saying that at any given point in the line, if you think about a normal distribution that's going across this line, across this line, across this line, across this line, the standard deviation, or about 67%, would be about 750 on either side of attendance. Next step, let's take a look at the residuals. So remember, to get them, you have to go here where it says linear fit, and we click on the red triangle. We're going to go down and say plot residuals. And then we've got 4 different plots here, and I've asked you to look at the residuals by predicted. That's the first one that JMP gives us. So let's grab that one here. Control C, go to my Word document, paste special, bitmap. Okay, there we go. Okay, so we're looking over here and we're seeing that there is what looks to be like a normal distribution, but by the same token we have a very long tail over here. And so is it a radical departure enough from normality to call in the data scientist and halt the analysis? Maybe not, but it is something that can be worrisome because it definitely seems to be deviating from normality here. So we might say not enough, but still we should be concerned that other variables are needed. And why might we also know that? Because we could say that we have only 37% of the variation explained. So there may be some other variables that explain this stuff up here. So if we were to stop here, we do have quite a number of records doing the predictions, so we probably can rely on this p-value to tell us that we can reject the null hypothesis, but we would not necessarily be satisfied with these results from a business point of view. So we can say that the model passes the technical tests with a slight caveat about the residuals, and does it pass the business test? So at this point the question is whether or not you noticed in the lab what the standard for the business test is, and that comes right at the end of this first paragraph here where it says she figures that if she can predict attendance within about plus or minus 300, she will be able to effectively adjust part-time labor. And so what was our RMSE? Was 750. So right now our typical prediction is going to be about twice as far off as she is comfortable with for saying that this analysis is going to be a success. So at this point we can say that we do not have enough power, that is to say, well, let's say enough predictive accuracy to say that she should use this model. So not yet suitable for use. And I would go about explaining that in much greater detail here in a whole paragraph, writing down the things that I just said in words for you. So at this point we want to see if we can find more variables that will help make a more accurate model. So that's the end of question 4.